So when we compare the reaction of aluminium with acid, so what we observe, as we know, when metal react with acid, this will give salt and hydrogen. So aluminum is a metal, react with say hydrochloric acid, HCl. This will result in a formation of salt, aluminum chloride, AlCl3 plus hydrogen. So first we should balance hydrogen. What will be the balance equation for this? Yeah, what will be the balance? We balance oxygen followed by hydrogen and at the last other element. This is a equation is completed but not balanced. What will be the balance equation for reaction between aluminum and hydrochloric acid? So 2, 6, 2, 3. This equation is balanced. What I will observe when this reaction will occur? What will be the observation? We'll see bubbles, that's right. And what else? Two observation if I say. Bubbles or fizz is one because hydrogen is a gas. And what is the second observation for this reaction? Yes, instead of mentioning melt, melt is a thing which is done by heat. So yes, solid dissolve is a better term rather than dissolve, reacted, solid size decrease. But if you say melt, it means you supplied heat energy. So melting is not a proper term which for this. Here we have aluminium. So aluminium will dissolve or solid dissolve. These are the observations. So when I sketch a graph, if I say sketch a graph for time and the volume of the hydrogen, which is collected versus time. So what we observe here, we observe a different type of graph. Like in the beginning, the reaction is slower, then suddenly the reaction speed up and then the reaction slow down. This type of graph, normally if we sketch a graph for rate of the reaction for volume of a gas, the normal graphs in the beginning they're faster because greater amount of reactant. So normal graphs for volume of a gas in time are like this. In the beginning steeper, then slow down because the amount of reactant decrease and eventually stop. But with aluminum we find initially it is slow. Initially it is slow, then suddenly it became fast, and then again it slowed down. What's the reason why a graph having different pattern? So the reason in case of aluminum, this can happen with other metals also, but not for every metal. Like magnesium, it happened for magnesium as well. So what is the reason? Because what happened as we have aluminum, like example, this is a piece of aluminum. This aluminum reacted with atmosphere, and the top layer of aluminum is actually not aluminum. The top layer is aluminum oxide. And metal oxides are not reactive. So even you have a pure aluminum, but that top layer of aluminum will turn into aluminum oxide. And aluminum oxide does not react faster. Metal oxide does not react faster as compared to metal. So that's why when you first add an acid HCl, first the acid was reacting with metal oxide, that's why the reaction was slower. But once the oxide layer is removed, like once this oxide layer is removed from the metal, now the metal is exposed. As the metal is exposed, then the reaction becomes steeper or faster. And why the reaction slow down? Because now the amount of reactant is decreasing. That's why the rate of the reaction decreases. So at point A, what was happening? At point A, you was having an oxide layer, which is reacting with an acid, and it is reacting slowly. That's why the reaction was slow. But at point B, all the oxide layer or oxide layers is removed. Now the metal is exposed to the acid. That's why the reaction is steeper. And eventually what happens once all of the amount of the reactant is decreasing, that's why the rate is decreasing. So C is because the amount of reactant is decreasing, and A is because of oxide layer. Is it clear? At A, the reaction is at B, reaction of acid with metal, and C, it slow down as amount of reactant decreases. So the metals which have oxide layer, generally in the beginning, their reactions are slower. Once the oxide layer is removed, the metal is exposed to the acid, then the reaction rate is faster. And again, the reaction rate slow down because the amount of the reactant or number of the particle decreases. Is it clear? The reactions of aluminium with acid? Any doubt in this part? This can be explained in terms of exothermic, but the thing is, initially the rate is slower because the temperature is low, as well as the oxide layer is there. And the second thing, when the reaction occur, heat is given off, that heat increases the temperature, and oxide layer is also removed, so the reaction rate increases. So you can explain in terms of temperature as well. This is not only happen for aluminum, it can happen for other metals also, like magnesium. With magnesium also it happen. So the reaction initially slower because of magnesium oxide layer. Once oxide layer is removed, the temperature also increases. The rate increases because of removal of oxide layer as well as change in temperature. Then the properties of the aluminium and use, like example, the uses of aluminium. Number one, we can use for aircraft bodies. So what could be the reason why we are using aluminium for aircraft bodies? Lightweight or low density, that's one thing. Lightweight or low density, you can mention, as well as and strong, because it should be a strong material. It will not break. Then we can also use aluminium for overhead cables, like high tension wire. So what could be the reason why we are using aluminium for overhead cable, high tension wire? Conduct electricity, that's one thing. And again, because high tension wire elevated above the ground, so it should be easy to lift them. So good conductor and low density. We also use aluminium as very common use for aluminium. You can find containers, food containers made up of aluminium. So what could be the reason why we are using aluminium as a food container? Not for cooking purpose, like as a container, we are keeping it inside. Yeah, so it resists corrosion, anti-corrosion or resist corrosion. Due to oxide layer. So these are some uses of aluminium. So we will discuss now questions related to this topic, extraction of aluminium. Question 3. What could be the answer for question 3? Everyone should participate. It's not an issue even your answer is right or wrong. Which statement about the uses of the metal is correct? Aluminium is used in manufacture of aircraft because of its strength and high density. That's wrong. Copper is used electrical wiring because of its strength and high density. That's also correct and wrong. Low carbon steel is used to manufacture car body because not because of its strength. It's Stainless steel is used in construction of chemical plant because it resists corrosion. So D is the right answer, but about the stainless steel we will discuss. Corrosion means the metal surface develop an oxide layer which reduce the strength of the metal. We call that as a corrosion. You will study about the low carbon, the types of the steel as well. So then you will understand like the difference between the low carbon steel and the stainless steel. Question 4. Which statement about the process is not correct? So aluminium ions gain electron during electrolysis and reduce. Yeah, that's true, because again, cryolite is added to reduce the melting point. That's correct. Anode and cathode made up of graphite. The cathode has to be replaced. No, not cathode. The anode has to be replaced because the oxygen reacted with graphite carbon. That's why it must be replaced. Question 9. So for question 9, what is the cryolite during extra, like why is cryolite is added to aluminum for electrolysis, not a catalyst? It lower the melting point. It protect, no, it separate. That's also wrong. So B is the right answer. Question 12. What could be the answer? Yeah, D is the right answer. Why others are electrodes are made, because which is not correct. Aluminium is a positive ion, so it does not move towards the anode, it is attracted towards cathode. So this is true. Formula of aluminum oxide is also correct. Purpose of the cryolite is to lower the melting point. So D is not a correct answer. Question 24. What could be the answer for question 24? So ore of aluminium is bauxite, and it is aluminium is attracted towards the negative terminal. Question 28. Which statement about industrial extraction of aluminium from aluminium oxide is correct? So aluminium is extracted by heating. Carbon is less reactive, cannot be done. It's not moving towards anode. Platinum is not used. We use graphite, so we are left with D. Molten cryolite is used as a solvent for aluminium. Why we call it solvent? Because amount is higher as compared to aluminium oxide. Question 32. What could be the answer for question 32? So you can see a similar question repetition is there. Cryolite, like what's the reason of a cryolite is to decrease the melting point of electrolyte. To protect anode, wrong. To produce more aluminium, that's not the main purpose. It increases the concentration of the ore and stop aluminium from reacting with the air. That's also wrong. Question 35. Question 35. Yeah, 35. Which statement is not correct? Aluminium ions are oxidized, means oxidation is a loss of electron. But what happened? Aluminium ions gain electrons. So when something gain electron, we don't say it is oxidation. We call that as a reduction. So this statement is not correct. Carbon dioxide is made at anode. That's true because of carbon react with oxygen. Cryolite is added to lower. That's correct. Electrode are made up of graphite. That's also correct. And this change is called reduction, not oxidation. So A is not correct. $39. So 39, anode and cathode both are made up of carbon. And which one will move towards the anode? Oxygen will move towards anode. B is the right answer. Question 43. So the purpose of the cryolite, it's used as a solvent to lower the melting point, as a coolant to prevent the no, it's not. Look, there's a difference between a coolant means something which absorb energy or remove energy. Like example, in a car radiator we are using water as a coolant because the water absorb energy from the engine, the which is released from the engine. But here aluminium, the cryolite is not absorbing energy, it lower the melting point so that it can melt at a lower temperature or use as a solvent. So C is the right answer. Coolant is a substance which remove the heat energy. Aluminium objects do not need protection from corrosion. Like we don't have to paint them, we don't have to put a grease or any electroplating. Iron object must be protected from corrosion. Why does aluminium resist corrosion? Because it has a protective oxide layer. That's why aluminium does not uh, rust or corrode. Question 53. Then we'll do the structure questions of this topic. So molten cryolite dissolve the aluminum oxide. That's why we use it. Question 57. So again, you can see a molten cryolite is used to dissolve aluminum oxide. Now some structure questions related to this topic, extraction of aluminum. Why not A? What was option A? Aluminium ions are oxidized. No, when something gain electron, we call reduction, not oxidized. Aluminium gain electron. Okay, in this question, aluminium is a very important metal. Aluminium is extracted from the ore by electrolysis. Bauxite is an impure form of aluminium. Describe how aluminium is extracted from bauxite and include an ionic half equation for the reaction at each electrode. So we have to write equations as well. So what we will do, the whole process. So this whole process you have to mention, like what happened in this process, extraction of aluminium. So first what we will do, we have a bauxite. So we will add sodium hydroxide, but you can see not too many details. So we will add sodium hydroxide, then filter and heat to obtain aluminium oxide. Then add cryolite. Add cryolite to lower the melting point. And use electrolysis. So when we use electrolysis, the ionic half equation at anode, oxygen ions will move there. So they will lose, one oxygen will lose 2 electron, 2 oxygen will lose 4 electron and form oxygen gas. An aluminium ion attracted towards cathode, it will take 3 electron, change to aluminium metal. Yeah, that's right. Bauxite treated with sodium hydroxide, remove the impurity. Then explain why anode have to be replaced regularly. So basically, the oxygen reacted with the carbon due to high temperature and form carbon dioxide. So size of anode decreases. Because for extraction of aluminium, you have this electrolytic cell. So oxygen ions are attracted towards anode and the size of anode decreases because of formation of. So what happened as at this part, oxygen ion attracted towards the carbon, the cathode, anode. Carbon reacted with oxygen and this result in a formation of carbon dioxide. Then give two uses of aluminium and give a reason why aluminium is suitable for each use. This will continue next session. I'll share another link because this will end